Hi Year 12, I just thought I'd put together a video of it's me talking you through how to do all these questions rather than just sending out work solutions, with it being your first test on UA level content. So the first one, if we're fully factorising that, at the moment the easiest thing to take out would be taking out x. So if we factorise x out of that, we would get x lots of 25 minus 9x squared. Then it's a case of spotting that that is a difference of two squares, and you can tell that because it has a 25 there, which is 5 squared. It has a 9x squared, which is 3x all squared. So we'd have x lots of 5 plus 3x, 5 minus 3x. That's question 1. Question 2, a powers based one. So if we firstly expand the bracket on the top, we would have to do 2 cubed as well as doing x to the half cubed, which means that we would have 8 lots of x to the 3 over 2, because we times the powers, divided by 4x squared. 8 divided by 4 gives us 2. X to the 3 over 2 divided by x squared would mean we subtract the powers, and 3 over 2, or 1.5, take away 2 is minus a half. So you could have that as your answer, or you could have 2 over x to the half, or 2 over root x. They are all the exact same thing. Always check though to see if it wants it in a particular form, because if it does, you have to go along with that form. Okay, next one. Show that 2 over root 12, because that's meant to be a root of all of that, and a root of that, minus root 8 can be written in the form root a plus root b, where a and b are integers. If this comes up in your test, then it would be a case of they say you must show you're working, because we won't have non-calculator tests as a rule at A level. So you'll have it, but you will have to explain it along the way. So this one, there's 2 ways you could go about it. We could go straight into rationalising, or we could simplify. I'm going to choose to simplify just to see if we make this a bit nicer first. So root 12 would be the same as root 4 root 3. And root 8 is root 4 root 2. So we have 2 over 2 root 3 minus 2 root 2. So it's not great. It's not much better than before. Some people might find it worse, but at least we've done the simplification. Now, to rationalise a third, we times the top by the conjugate of the denominator and the bottom by the conjugate as well. Now, the conjugate means you get this thing on the bottom and you just swap the sign, so that's why it's a plus. If this had been a plus, we would have swapped it to a minus. It's just whichever the alternate sign is. So on the top, we essentially have to expand the single bracket, 2 lots of 2 root 3 plus 2 root 2. And on the bottom, we have to expand this double bracket. Now, I've just realised we could have actually divided the whole thing by 2 to make it more straightforward, but we've got this far now, so we might as well continue with it and can divide by that 2 later on, hopefully. So the numerator will be 4 root 3 add 4 root 2, and the denominator, you would end up with 4 root 9. You'd end up with 4 root 6. And from those 2, you'd end up with minus 4 root 6 from those 2, and you'd end up with take away 4 root 4. So these cancel, And we're left with 4 root 3 plus 4 root 2 over, that's 12 there, and that's minus 8, because it's 4 lots of 3 and 4 lots of 2. So it's over 4, which means that we have root 3 add root 2. It's the same as that. Question 4. Find the set of values of x for which that is greater than 1 minus x. These questions typically do at first cause confusion, but you can just pretend it's an equal sign essentially while you're doing the working. It's no different in this method to rearranging the terms of an equation. Just because it's got an inequality sign doesn't change that. So expand the bracket first. If we add the x to the other side, we would get 7x add 8 is greater than 1. Take away the 8, and we get 7x is greater than minus 7, so x is greater than minus 1 when we divide by 7. Now, the one thing to be cautious of on this is that you can divide by a negative, but if you divide by a negative, it swaps the sign around. Let's see what happens if I did it the other way around. So, for example, if I took the 6x off the other side and then took away 1, if I divide by minus 7, I would get minus 1 there and x there, but it wouldn't stay that way around. If you look, that is different to what we have here. If you divide by a negative, it swaps the sign around. If you don't want to deal with that, just avoid dividing or multiplying by a negative. Just move the x over to the other side to make it positive, like I did in the first version. Question 5, always done quite badly. So these ones are always a case of the numbers can be written as a power of something. So for example, here it's saying, right, this is in the form 3 to the y. That's because this here is 3 squared. So we can write this thing in the form 3 to the y because we're going to have 3 squared to the 3x plus 1, which is 3 to the 6x add 2. And the only way that would ever be true is if this here is equal to this there. So that would mean that y has to equal 6x add 2. Right, 6. So next one looks like it's a factor theorem question essentially, but they haven't mentioned it at the beginning. So if you put in 5 into this equation, we get 0 equals 5 cubed plus 5 squared add 5p add q. So that means that 5p add q would equal, well, that's 125 and 50, so minus 150. If we put minus 3 into this, then we get 8. So we get minus 20, so we do minus 3 cubed, add minus 3 squared, minus 3p add q. So that means we get 8. If we add on the 27, that makes 35. And if we take away the 9, that is 26. So we've got minus 3p plus q equals 26. So now if we solve these two, nice and straightforward ones because we just have a single q. So I'm going to do equation 1 take away equation 2 to get that we have 8p plus no q's equals minus 176. And if we divide 176 by 8, we get that it's 22. So P is negative 22. And now that we know that P is negative 22, we substitute that into one of these, and we get that, so probably going to pick the bottom one because it's got smaller numbers. Minus 3 lots of negative 22 plus Q is 26. So minus 66 plus Q is 26. Q is 92, sorry. So there are two values for P and Q. Right, B. It says factorise it completely. Now this is where the factor theorem comes into play, because if f of 5 equals 0, that meant x minus 5 is a factor. So if we divide this equation through by x minus 5, we should be able to factorise it. And our equation is x cubed plus x squared minus 22p add 92. And if I divide this through by x minus 5, we should hopefully have an answer. So you see how many x's go into x cubed? They go in x squared times. So let's multiply through x minus 5 by x cubed to get x cubed minus 5x squared. And if we subtract them, x cubed minus x cubed is nothing, and x squared minus negative 5x squared is 6x squared. Right, then we time how many x's go into 6x squared? It's 6x. And we bring the negative 22p down. So times these both by negative 22, sorry, by 6x, and we get x times 6x is 6x squared. Oh, not negative 22p, negative 22x. Made a mistake there. That would be minus 30x. And if we subtract them, let's give myself some more space, we end up with 8x. And if we bring this 92 down, so how many x's go into 8x? It's 8 times by 8, and we get 8x minus 40, and this should normally equal 0. So that tells me I've made a mistake somewhere. I see where my mistake was. So if we go back, relatively minor mistake, but I shouldn't do it. Minus 3 times minus 22 is positive 66. So I should have had this turn out to be minus 40, which is good, because if that was minus 40 and I brought it down, I do get 0. So that means that x cubed plus x squared minus 22x minus 40 is x minus 5 times x squared plus 6x plus 8. And we've known how to factorise quadratics for years, so we just factorise this into x plus 4, x plus 2. And that would be it completely factorised. Right, use the factor theorem to show that x plus 2 is a factor of f of x. Again, put in minus 2. And we will get 0 because that is minus 16, minus 28, add 20, add 24, which turns out to be 0. Factorise it completely. Let's do another division. So that must mean that we can divide by x plus 2. So how many x's go into 2x cubed? It goes in 2x squared times. How many? Then we times through by x squared, 2x squared, and we get 2x cubed add 4x squared. And then subtract to get negative 11x squared. And bring the minus 10x down. X's into minus 11x squared go negative 11x times. And if we multiply through x plus 2 by minus 11x, you get minus 11x squared minus 22x. Minus 10x, take away negative 22 is 12x. And 12x goes into x 2 times. No, it doesn't. It goes in 12 times. What am I on about? So 12. So then if we times it by 12, we get zeros. So it factorises to x plus 2, 2x squared, minus 11x plus 12. And using whatever your preferred method is for factorising, hopefully we should get that this is minus 4 and minus 3. Yeah, that turns out to be negative 11x and positive 12. So that is question 7b. Question 8 starts off with some completing the square. So if we want to complete the square on this section here will never change. You'll always end up having x and then something squared, take away something, and the minus, the add 19 will come down. So to get it, we have negative 8 to get negative 4, and we take away that thing squared, which is 16. So we would have x minus 4 squared add 3. Part B, the curve C with equation f of x, so this quadratic curve, crosses the y-axis at P and has a minimum point at Q. So, sketch it. The minimum point for this is at 4, 3. You end up swapping the sign every time on the thing in the bracket to get your x coordinate, and then you keep the same y coordinate. So that is at the coordinate 4, 3. And it crosses the y-axis. Well, we can get that from here. This always gives us our y-intercept, which means it crosses at 19. And finally, part C, it's saying, well, over here on the y-axis we have the point P, and here's the point Q. Well, what we have is, to find the length, it goes down by 16 and across by 4. And because up is 90 degrees from right, we've got a right angled triangle. So to find this length, we would do Pythagoras and do 16 squared and 4 squared and then root it. So that 16 squared is 256. Add 16 is 272. And to simplify that, what number's going to 272? It turns out it's 16 times 17. So that would be 4 root 17. Right, 2 questions left. So if we're trying to solve a simultaneous equation, when it's not one with that's linear, so it's not just letters equaling a number, we do have some powers in there, we need to rearrange this to either be x equals or y equals, essentially make x or y the subject. So let's just go for x is equal to 2 minus y, because then we can substitute this for 2 minus y squared. So we have 4y squared, take 2 minus y squared is 11. When you expand that, you've got to remember it's double brackets, so we get 4 minus 2y plus y squared. And the other thing you could slip up on is we've got to subtract these things. So we actually are taking away 4, but we're adding a 2y and we're subtracting a y squared. And that would mean that altogether we have 3y squared, we have positive 2y, and minus 11 take away, minus 4 take away 11 is minus 15. So if we factorise this, we would get, let's see, minus 5 plus, is it minus 3? Okay, the way that I normally do it is I need 2 things that times to negative 45 and add to 2, which would be 9 and 5 don't work, and 3, we might have potentially one that doesn't solve via factorisation. We might have to get a third answer. Unless I've made any mistakes. Yes, I have. Right, so back here, minus 4y. Okay, so times to minus 45 and add to 4, which is to do with 9 and minus 5. So if we go to the answer, now that I have one that I can actually do, I believe we get y plus 3 and 3y minus 5. So y is 5/3 and y is negative 3. But you've got to remember that you also need a corresponding x coordinate. And we said x is equal to 2 minus y. So x is what, 2 minus 5/3, which gives us 2/3. No, it don't. Gives us 1/3. And x is 2 take away negative 3, which gives us 5. So our 2 coordinates where it meets, because that's one valid way of writing this down, are 1/3, 5/3, and 5 minus 3. Okay, last one. If it's true for all odd numbers we use 2n plus 1 or 2n minus 1. So if we do 2n plus 1 cubed, and we take away 2n plus 1, then this will expand to 2n plus 1, 2n plus 1, 2n plus 1. Will eventually, if you work them all out, get us to 8n squared, cubed, sorry. You end up with 4n squared, add 8n squared, which is 12n squared. For the n's, you get 6n and 1. And then we're taking away 2n plus 1. So we have 8n cubed add 12n squared. 6n take away 2n is 4n. And 1 take away 1 is 0. So that means it is even because... Oh, so it's a multiple of 4 because we can factorise out 4. And then you've got that it's a multiple of 4. Last very quick question. Use the counterexample to show that it's not always true. Then we just... Well, the hint from this is that it says that it's true for all odd numbers, so let's check an even number. And if that doesn't work, that can be the counterexample. So, I don't know, let's put in 2. 2 cubed minus 2 is 8 take 2, which is 6. So, yeah, that is not a multiple of 4.